Alright. Hey folks. I don't know if you can hear me right now. I'm not sure if this microphone's working. I'm going to grab another microphone. But we are going to be streaming Asteroid 2018 RC. And that's actually what's visible right in the center of this image. So hang on a second while I try to improve the audio quality. Alright. Alright. Can you hear me now? Oh. Yeah, you can probably hear me loud and clear. Sorry, I was looking at the wrong... Oh, I was looking at the wrong bars in OBS here. Okay, I think I've got loud and clear audio, probably too loud. I'm going to pop into the chat here. You guys let me know how the sound levels are. You may have noticed I am not your usual host. This is Astronomy Live, taking over Red's Rhetoric channel for the night, with his permission, of course. And we're going to talk about that in a moment. This is, for now, my new home, both physically and digitally. So we'll get into that in just a moment. Let me pull up the chat here. And while we're doing that, let me zoom in on the asteroid. So this is Asteroid 2018 RC. It's currently between the Earth and Moon. It was just discovered recently, and it's making a very close approach tonight. So I'm going to be tracking it here. It's actively being tracked by my telescope using my custom tracking software. Pardon for the stray light there in the telescope momentarily. I was just checking, making sure all is good there in terms of the dew formation and stuff. I've got the dew heaters on.
And stuff. I've got the
looks like we're
dew
all
heaters
good.
on.
And you guys can actually, looks like you might actually be able to see my mouse cursor, which is kind of interesting. I wasn't sure if that was going to really work. I haven't really done a space webcast this way using OBS instead of Google Hangouts before, so I'm still getting used to the setup here a little bit. Bear with me. People are wondering who I am. So I am Astronomy Live, and this is obviously not your usual host, but Red and I had a talk. Basically, here's the deal. Back during the Falcon Heavy launch, I applied for YouTube ad monetization on my channel, Astronomy Live. But after about 6 months of YouTube reviewing my application, they finally came to the conclusion that no, I may not monetize my channel. They stated the reason was duplication, and this is a reason they're giving out to a lot of people they're denying right now. And according to other people who have done analysis of this based on the channels that have been rejected for that reason, there are some that seem to be rejected potentially for copyrighted material that wasn't claimed but was found during the review process, and some that were entirely original content, but they were still labeled as duplication, which can mean you are copying videos from other channels, or it can simply mean you're copying your own videos. So, for example, if I launch, or if I film a launch and then upload the raw, unedited footage, and then a couple days later I upload an enhanced version, and then a couple days later I upload a version where I break it down and do an analysis of it, they may consider that duplication. And they're stating that as a reason to not monetize channels right now. And oh, hey, are we getting... Hey, that might not be good. Where is my... I'm going to take a much longer exposure here. I'm thinking we might be getting frosting on the CCD here. I've got it set down at -5°C, and this camera has a built-in desiccant plug that is supposed to suck out the humidity to prevent frost forming on the CCD, but it has to be recharged about every 6 months. Here in Florida, the humidity is so high that the desiccant plug gets saturated pretty quickly. And there's a baking process where you literally stick the desiccant plug in the oven for a few hours and bake out the humidity so that it can start reabsorbing the humidity out of the CCD again. So I'm running these really short exposures that may not reveal the full state of the CCD. So I'm going to run a much longer exposure here for a moment just to see what the situation is there. Yeah, see all this? On the left we've got all these little donuts. That indicates the desiccant plug is getting saturated, and it is saturated, and now we're starting to get frost forming on the CCD. So I'm going to have to warm the CCD up, unfortunately. It's been a while since I've run my deep space camera. I was a little afraid that was going to happen. So that's okay. We'll just let it warm back up. It's at -4°C, as you can see on the window on the right. So I'm going to let that warm up to positive temperatures and thaw out. That's why I'm getting this haziness on some of these stars. It's because of the frost that's actually forming on the CCD. The lower the temperature, the less noise you get in the camera, so it would be nice, but for tonight, this asteroid's so bright, it's about magnitude 12. Still far dimmer than anything you can see by eye, but it's bright enough for the telescope that it's not much of a challenge to image it. So now we're at positive temperatures. I'm just going to go ahead and take another 30-second picture here and just monitor the frost, make sure it's going away. Okay, so back on subject here in terms of how I got here, why I'm your host tonight, and why you may be seeing me more often on this channel. Since YouTube has decided that my channel is duplicative material, duplication of other material, potentially even my own material, I am going to do everything I can to reapply. They're forcing me to wait about a month before I can reapply. I will do everything I can to remove, anything using copyrighted music. I have permission to use music from Stellar Drone, written permission, and I'll be sure to point that out to their system as well. But I think the crux of the matter is going to end up being that they don't necessarily like the kind of content that I upload, and they may not approve it for monetization regardless. Things like ambient videos, they may even consider this an ambient video, long footage of repetitive material. Well, I'm sorry, I think a lot of people find this interesting. We're getting to see here tonight an asteroid flying between the Earth and the Moon that was just recently discovered, and we're going to monitor it here as it flies by Earth. So I think that's pretty cool. Okay, so frost should start going away now. And these images are being recorded, and of course I can upload a time-lapse later, but I think people like to see this as it's happening, and so that's the kind of material I provide. And now I'm going to be bringing that here to this channel, to Red's Rhetoric's channel, with his blessing. So when I do live streams now, these are going to be taking place on his channel, and any super chats, any donations people want to make, that will ultimately come to me if it occurs on one of these videos that I'm hosting. Through an agreement with Red, If anyone wants to donate, then I can receive those donations through Super Chats on his channel. So basically, my goal is to use any ad money, any ad monetization, any donations to fund the purchase of equipment such as a permanent observatory. I just moved into a new house, and I'd like to provide a lot more webcasts like this, especially transient events where an asteroid's coming through and people want to see it. That's a lot easier to do, of course, if your telescope's always set up and all you have to do is head outside and power it on. But that requires a significant investment, so I'm saving for that, but you know, that's going to require a significant investment, and hopefully through ad monetization and other means, other donations, that can be defrayed somewhat. I'm also developing a lot of open source software for astronomy, including the very software that's tracking this asteroid right now. This is being tracked by software that I've developed for my LX200, and that is allowing it to directly track the asteroid. The asteroid is the bright object we see here in the center. The stars are these lines streaking by like rain. The telescope is tracking that asteroid, and you can see how quickly that asteroid moves. In just 30 seconds, the stars have already moved significantly. So if I weren't tracking it, it wouldn't stay in the view too terribly long. It would stay in the view for a few minutes, but then it would require me to move the telescope to keep up with it. With my software, it automatically tracks it directly. And that's a capability that previously wasn't present on the LX200, so kind of cool, I think. So yeah, it seems like the frost here is going away a little bit. I'm going to take these exposures down to 10 seconds. So we get a little bit faster refresh. So these are 10-second exposures now of the asteroid. And now I know what I'll be doing tomorrow. I'll be baking the desiccant plug to get the humidity out. So now all these colorful dots here, these are hot pixels. These are defective pixels on the CCD. Every CCD has these. But in astronomy, we see this very frequently when you run long exposures. So the camera's now taking a dark frame where it closes the shutter, and it takes a picture with the frame closed, the shutter closed, and then it subtracts that image to get rid of those hot pixels. I should also point out, just for record keeping here, that the telescope is currently alt-az aligned, so we are not polar aligned tonight, so field rotation will be a potential factor, and that can result in apparent rotation of the field of view as the asteroid progresses. Doesn't mean the asteroid is curving per se, although due to parallax you will notice that kind of thing. Let's take it up to 15 seconds here maybe. But simply due to field rotation, you'll see that happening. And interestingly, I think we might even pick up a hint of the asteroid's rotation as it is going by Earth. Not based on the shape. It's too far away. It's, I think, about 200,000 kilometers away right now, so a significant portion of the distance to the Moon. And that's slant range, by the way, from my current site, not necessarily from Earth's center. But due to its rotation, it can exhibit a change in brightness over time, and depending on how fast the rotation is, you can notice that even over just a couple of minutes of time, potentially. So as we watch the images here, I'm going to maintain 15 seconds exposure, but if it suddenly gets a lot brighter or dimmer, that would indicate, you know, rotation is present there. Because I think I've seen it get a little bit dimmer at times, so I think that is potentially due to its rotation. Now, this is a relatively small asteroid, so it may not have a terribly round shape. It could be quite lumpy in shape, and so depending on its rotation, it could be presenting more or less surface area to reflect light to the telescope, and that can result in a change in the light curve, as we say in astronomy. If you measure the light over time, the brightness over time, you could get a light curve, and you can actually see this sine wave of the rotation of the asteroid. So let's see here. Yeah, there's quite a few articles about this asteroid over the last couple days since it was discovered. Some of them a little more sensational than others, such as Daily Express, NASA Asteroid 2018 RC warning, newly discovered asteroid to skim Earth on Sunday. Yeah, it's not exactly going to pass through the atmosphere, but it is going to be coming quite close. Let's see. Planet center. Let's see here. Now, let me... Actually, I've got Find Orb open. Let me just calculate what is the close approach distance. Close approaches... Yeah, sure. Close approach was earlier today at about 230,000 kilometers. So it is getting further away from Earth's center now, but due to the rotation of Earth, according to what I was seeing earlier, it might be past this point now, but for a while it was actually carrying me closer to Earth from my position on Earth's surface. The point at which I'm actually physically closest to the asteroid, the telescope is closest to the asteroid, occurs a little bit after the asteroid is actually starting to get further away from Earth due to Earth's rotation, which is kind of interesting. But at its closest to Earth, it was about 230,000 kilometers away, thereabouts, according to my calculations of its orbit. And let's see here. What is the asteroid's magnitude? Okay, I calculated an absolute magnitude of 24.6. So that corresponds to... Let's figure out what size of asteroid that corresponds to. Oh, looks like JPL's got a new asteroid size estimator calculator thing. That's kind of handy. That's 24.6. And that may not be the official absolute magnitude, but it's just what Find Orb calculated for me. So it depends on how reflective it is. It could be about 70 meters in size, maybe even if it's really, really a dark asteroid, up to about 0.1 meter, or sorry, 0.1 kilometer, or about 100 meters in size. If it's say 5% reflective, about as reflective as asphalt, then it's about 70 meters in size. So yeah, not a huge asteroid, and asteroids of this size can really sneak up on Earth at any time with basically no warning, because our telescopes can only see them when they're right on top of us. There are telescopes scanning the skies every night trying to discover new asteroids, but the asteroid has to be in a certain range to make it bright enough for those telescopes to detect. And that's the problem. That's the limitation there, and that's why you don't hear about these until potentially just days before, and sometimes even after they've made their closest approach to Earth. So, Super Chat. Marty Rules, thank you for your donation. He says, hope you get your channel monetized again. I hope so. It was never monetized to begin with, and I fear it never will be, as it stands. Mexican's Wrath says, you okay, just give us a cuss word here and there. I'm not accustomed to doing that, unfortunately. Sorry, I'm not as entertaining as Red in that sense, I guess. Thank you for your donation as well. So yeah, it's quite unfortunate, the bind that YouTube has sort of put me in. And, you know, one thing I'm doing right now is I'm in the process of porting the software that's doing the tracking right now. I'm porting it to Python, and that will allow me to use more advanced features in, say, OpenCV. That's the library that I use to do computer vision tasks, such as tracking rocket launches and things of that nature. And so by porting it to Python, I can utilize those utilities a little bit better than I can in, say, Visual Basic, which is what this was originally written in. And it will also allow me to more easily port it to other telescopes. For one thing, I would like to port at least some of the functionality to ASCOM-based telescopes. Now, as far as this kind of dynamic continuous tracking, that's going to require a certain command compatibility in ASCOM. ASCOM is a universal driver set for telescopes. My telescope has an ASCOM driver, for example, but my telescope's also much older than most telescopes these days, and so unfortunately it's not compatible with that continuous tracking command. So that's why I wrote this software for tracking objects like this asteroid to begin with, because there was nothing out there that could do this, for my scope at least. For other scopes, there's already packages out there that can help you track comets and asteroids and stuff, but I think this would be still a handy utility for a lot of people, and also the ability to use a joystick and computer vision to track rocket launches could be quite handy for a lot of people as well. And so my plan is to port that to Python so that I can at least offer that functionality for people who have telescopes that are a little bit more recent and compatible with that continuous tracking command called, I think it's called move axis is the command. So move axis lets you slew the telescope at an arbitrary speed, so you can specify, I want you to turn at 5 degrees per second in this axis and 2 degrees per second in that axis. You can't directly specify that with my telescope, so I've had to come up with a workaround. But that workaround is not directly compatible with ASCOM. It's just not how ASCOM was designed. It wasn't designed for that kind of high-rate communication with the scope that this workaround requires. So, yeah, there's going to be some effort made to change that a little bit so that it is compatible with ASCOM, in addition to the workaround that I've already come up with, and so that you can pick what kind of scope you're trying to control with it. So that's all in the works as well, so I hope that provides a lot of utility to people. And again, I'm going to make it open source and freely available, but I hope if people find it useful, they'll donate and help fund more webcasts in the future, because like I said, I would like to do this a lot more often, but it's difficult, especially during the weeknights when it takes me at least an hour to set the scope up. Tonight I had to disassemble the adaptive optics unit that I normally use, because adaptive optics requires high-speed guiding on a star, a background star. Now, if in this situation, you can imagine what would happen if I set the adaptive optics unit to, say, guide on this star that's coming into the view at the left here. The asteroid would just streak right out of the view. The asteroid would not stay stationary enough to benefit from that. This is a fast-moving object. So if I told the telescope center up on this star and stay perfectly still and hold that star in perfect position with the adaptive optics unit, this asteroid turns into a faint streak and you only see it for a couple minutes, so not useful. So I had to disassemble that tonight and get the camera configured in a mode where it could track this asteroid. But that was just one step. If I had a permanent observatory, that would be the only barrier to doing this webcast. I'd only have to do that, get the camera back on the scope, and off I go. But as it stands right now, I have to set up all the equipment from scratch every single night, and then I have to tear it all down at the end of the night. So it's much more time-consuming and really only practical for me on the weekends. Fortunately, this asteroid's making its closest approach on the weekend, so that worked out. But, in the future, these things can come through any time, and I'd like to be able to do, webcasts during the week as well. And if I'm able to get a permanent observatory, I'll be able to do that. So I'll be looking into, maybe a Patreon type situation as well, perhaps. Beam Me Up Scott. Oh, did you make a big donation? I didn't see it. I hope it didn't. I hope your money didn't vanish. So Richard Ski was asking what YouTube has done to my channel. Well, it's what they haven't done. They're not approving me for monetization, and they say my channel has too much duplication, which could mean, you know, duplication of other channels' material. Like, you know, I've done debunking videos, and yeah, I might show somebody's video, but I do it in the context of I'm critiquing it. You know, it's fair use. I'm critiquing it. I'm analyzing it, and YouTube makes it pretty clear in their current criteria for new monetizations that fair use is not really a defense here, and they can choose who they will and won't monetize. It doesn't matter if it's fair use. If they decide they don't like what you're doing, they're not going to monetize you. Even if you're using all of your own material, if you upload very similar videos, they say, they may choose not to monetize you. And so, you know, if I upload multiple versions of the same launch, one unedited and one enhanced, they don't necessarily like that. But I'm not going to change my channel's direction just because YouTube said so. I'm sorry, I'm just not going to do that. Yeah, they may not like it when I upload multiple versions of the same launch, but I do it for a reason. Just this weekend I received another comment from somebody commenting on my Falcon Heavy video saying on the enhanced version, oh, enhanced, huh? That's one way to put it. In other words, they think it's fake, and I'm kind of admitting it by saying it's enhanced. Well, as I said to them in a reply, I said, well, you can view the unedited, unenhanced version as well, and here's the link. I had both versions up. In fact, I even put the unedited version up first. So that really left them no room to continue attacking me. And no, I don't think that's necessarily going to change people's minds if they think that, you know, SpaceX is faking their launches and their landings. You know, if they think I'm part of this conspiracy and I'm faking my videos, sure, yeah. Uploading multiple versions, it's not probably going to change their mind. But at least it leaves them no room left to attack me. It gives them absolutely no quarter. And, you know, he quit commenting after that, so I'm happy with that. That's what I call a result. So I'm not going to change my direction just because YouTube doesn't like it. So, interestingly, it seems like maybe the asteroid's dimmer right now. And it should still be continuing to gain in brightness for the current time being. Even though it is getting a little further away from Earth, it has to do probably with a phase angle, how much sunlight is shining on it, what the angle of the sun is to the asteroid, all that stuff. So, it'll be interesting to see if it gets a little brighter here in a minute. Yeah, no, the asteroid is not going to hit us. It's not a threat to hit us. In fact, it's already made its closest approach to Earth, and it's now starting to recede a little bit. Its closest approach was at about 230,000 kilometers. Yeah, see, it seems to me like it's getting a little brighter now. Just a bit. And can someone in chat let me know, can you see my cursor? Is my cursor visible? I think it is, from what I can tell. But I just want to make sure. So if I'm pointing at something, I'm not pointing at something that you guys can't see where I'm pointing as I'm pointing things out. And you may be wondering why the stars are not perfectly smooth lines. Well, that has to do with the limitations of this workaround that I've come up with for directly tracking on asteroids with the scope. There's a certain coarseness to the scope's coordinate format. The scope can only accept coordinates to the nearest second of arc. It can't do fractions. So basically it sort of stutters along at slow speeds. When you're tracking at high speed, you don't notice it. It doesn't matter. But when tracking relatively slow-moving objects, for example, the asteroid, yeah, it's moving with a quickness, but not quick enough that you can't see that. So you can see some sort of, you know, staccato to the streaks of the stars here, some varicosities in the lines. In other words, variations in the thickness as it sort of moves to the next tick of coordinates, and then again, and then again. So, yeah, it's not perfect, but it's pretty good, considering the scope's, you know, out of the box, not capable of doing this, not capable of directly tracking a fast-moving asteroid like this. Oh, you cannot see the cursor. Okay, so how about now? Did it appear when I clicked into the window? I'm going to click away from the window, so don't be surprised if it vanishes, but I'm just curious if there's any way to get the cursor to appear. There may not be. I don't know. Because I'm sharing the window, so I don't know if OBS is picking that up. There may be a setting in OBS, to be honest. I'm not super familiar with it. Let me see if there's a setting in here that would let me stream the cursor. Hide cursor over projectors. Not sure what that means. It's not checked. So I don't know. How long will it be at its bestest approach? Well, tonight's really the best night to see it. The asteroid's at about magnitude 12 according to JPL, and that seems about right for what I'm seeing here. And just these are what, 15-second exposures, and it's, you know, pretty bright. So that does sound about right. Magnitude 12 is way dimmer than anything you can see by eye, so you can go out and look at the stars tonight. It's a beautiful night, but you're not going to see it. Even with binoculars, really, it's a little bit below what you should reasonably expect to see with binoculars easily. Maybe if you had a really big pair, I don't know. But with a telescope, an amateur telescope like my 8-inch LX200, which is what I'm using tonight, magnitude 12 is doable. You should be able to see that in an eyepiece. If you get a good quality amateur telescope and you get some good sky charts to locate the asteroid. And in fact, here I'll plug somebody right now, and promise you I'm not getting any kickback for this, but last I checked, Sky Safari Pro had just released version 8 of their app, which is available on Android, and I believe it's available on the iTunes Store or the iPhone Store, whatever, the App Store on the Apple's App Store as well. And I believe they have it still for 50% off, as they've just released version 6. Yep, it's... oh. Okay, so it's... the basic versions are available for about 50% off. But looks like the Pro version on the App Store is the full $40. Now, for Android, I was pretty sure it was at $20 earlier today. I guess I should check and make sure that's still true. It may not be true. I don't know. Apps. Yeah, I don't know. I'm not seeing the sale on the Pro version now, but well, sorry if the sale, I don't know if the sale's still on for the Pro version, but it is on for the Plus version, which is really good enough for most people. I use the Pro version just because I want the maximum size database of objects. I use it all the time at the telescope. It's basically planetarium software that's as powerful as what you would find on a desktop, but it's available on your phone or tablet. And so go check it out. Really good sales on that right now, and you can use something like that to import this object. You should be able to import this asteroid into the program and see where it's at. or you could use Celestia, Stellarium, whatever your preferred planetary program is to generate sky charts. As you can see, it's moving relatively quickly, so you have to generate a sky chart that is temporarily relevant. You have to generate a sky chart based on the exact time that you intend to look for this asteroid. But it is theoretically possible. If you do that, you should see it moving in the eyepiece, which is kind of cool. It's not something you see every day, an asteroid moving, visibly moving by eye through an eyepiece. So go check that out if you can. Just in general, it is a little bit higher and to the east of Mars right now. Mars is rather prominent in my southwest sky at the moment, and this asteroid's not too far from that location in the sky. And I'm just saying that based on where I'm seeing the telescope point, of course. So let's see here. Oh, have I got a text message? What have I got here? No, an email. Security alert. Oh dear. One of you guys trying to hack me? Hope not. When was that? Oh, that's an old alert. Okay, that's not. I know what that is. That's not anything to be concerned about. Okay. So. I can see the asteroid a lot better with the P1000. I doubt that. Sorry, I doubt that. The P1000 is a nice camera, but this is an 8-inch diameter telescope. It's got a fair bit more light collecting ability. And, yeah, also auto-tracking capability. Really, really handy. Just for reference, I'm not auto-guiding this asteroid. I mean, maybe I could. Be a little tricky at magnitude 12. But I'm not auto-guiding on it. This is open-loop tracking with my software, so it's just tracking the asteroid based on the expected coordinates from ephemeris that I calculated using FindOrb. So basically I can export the coordinates, a coordinate list from FindOrb. My program will open that up and interpolate the current coordinates from that list and track it. And it does a pretty darn good job. We're going to see any explosions here? What? Well, hey, if we do, man, you saw it here first, right? I seriously doubt that. People underestimate how huge space is. I mean, it's cliche, but it's true. There's a huge amount of space between the Earth and the Moon. And man, I forget the math. I've done the math on it before. It's fun to do. Calculate how much volume is encompassed by a sphere with the radius of the Moon's orbit. It's huge. And so you quickly begin to realize how it is possible for so many asteroids to pass between the Earth and the Moon. You see it in the news all the time, and yet none of them manage to hit the Earth or the Moon, because we're actually very tiny in that huge sphere of space, and it's unlikely that any particular trajectory taken randomly through that sphere is going to intersect with the Earth or the Moon. Now, yes, we have gravity. We will tug on this asteroid's orbit a bit with our planet's gravity, but it's not enough to suck it in like a vacuum cleaner. That's not really how it works. And of course, Earth's gravity and the Moon's gravity are already accounted for in my calculations. So the telescope's tracking it based on the trajectory with Earth and the Moon's gravity included. So Kaiser asked what we're even looking at. So the streaks are background stars streaking by. The asteroid is the bright dot in the center of the view. Let me zoom out a little bit here just so you can see the big picture. So you can see quite a few stars here in the view, and the asteroid is right there. Near the center of that view. not bad for tracking accuracy, I have to say. I did a rather rushed job setting up the telescope tonight to get this asteroid. Wasn't super precise on the alignment, and I picked 2 stars for alignment that are relatively close to each other, which is not good. You want to, when you're setting up an LX200 like this, you have to align on 2 known stars so that the telescope can orient itself and know where it's pointed in space. And you really want to pick 2 stars on opposite sides of the sky to try to maximize that baseline and really get a good lock on the sky. And I just did a quick rush job tonight. I did Vega and Altair, which are 2 stars in the asterism of the summer triangle. And so they're not that far apart from each other, but they were handy and quick, so I used them. And even with that alignment, it's not doing too bad here with the tracking. That's pretty good. I can make manual adjustments if I have to, but I haven't made any. Let's see. What other questions have we got? JPL Lover says that he also has that app and uses a Celestron Nexstar 130 SLT. It's a good scope. And actually, the Nexstar, that should be compatible with my next version of this tracking software. I believe it does support the move axis command in ASCOM, so unless I'm terribly mistaken, it should be compatible through the ASCOM driver in the next version. So stay tuned on my channel for that. I will still upload videos to my channel. I'm not going to stop uploading to my channel. And actually, that presents a bit of a conundrum, because I could take tonight's webcast and I could re-upload that to my channel as well, much like how Red re-uploads videos to his Redshift channel. But the problem for me is if I do that, that's more duplication. YouTube may not like that. And I don't like the position YouTube's putting me in of making me question whether to even upload my own content for fear of pissing them off on my next chance at trying to get monetization going. I mean, it's absurd. But that's the conundrum I'm facing. So maybe I won't. Maybe I'll just upload a time-lapse, and they could still consider that duplication. I don't know. But I'll definitely try to upload a time-lapse of images from tonight's close approach. Beam me up, Mr. Scott asks what scope we're looking through. We are looking through an 8-inch LX200 Classic. So this is an older scope, originally built and designed. Well, I don't know when it was designed, but built and sold in the 90s. And this is one of the last of its kind. I bought it new right as they were phasing it out in favor of the new AutoStar LX200s. But this has the old Magellan computer system. So basically you can't update its database. It's permanently encoded with EPROMs, these chips that are in the motherboard that you can't alter the memory without physically removing them and erasing them. So there's no way to update the firmware on it shy of physically accessing the motherboard and pulling the memory chips out. And back in the 90s, when they did updates of the firmware on these scopes, that's what you had to do. You had to physically remove the motherboard and send it in if you wanted an update. So anyway, obviously there's no way to update it with a new asteroid like this one. The only way to do this is to connect it to the computer, which is what I've done. It's connected to my laptop, and the laptop is running the software that's sending the commands for tracking to the telescope. So the camera is an SBIG ST2000 XCM. It's a very nice camera. It's a one-shot color camera. It's got color filters built into the pixels, much like a consumer digital camera. But this is not a consumer digital camera in the sense that it's not your typical CCD camera. This has thermoelectric cooling. It's actively holding the temperature I tell it to hold. Right now it's holding it a set temperature of 5 degrees Celsius, and it's basically bouncing back and forth around that temperature. I can drop it to negative temperatures as we saw earlier tonight, but the problem right now with that is that if I do that, the CCD will actually start to frost up due to humidity in the CCD chamber. There's a desiccant plug that this camera has that is supposed to suck the humidity out, but it gets saturated. And about every 6 months I have to re-bake it, literally bake it in the oven to burn the humidity out of that desiccant plug, and then return it to the camera so that it can suck the humidity out of the CCD chamber. Because when it's properly operating, it should be able to operate at very cold temperatures. On a good winter night, I can easily get it down to negative 15 degrees Celsius in Florida, where it's still well above freezing. And even on a summer night like tonight, I can get it to sub-freezing temperatures using thermoelectric cooling. So that reduces the noise on the CCD, and also by holding a set temperature, by holding a consistent temperature, you are able to more easily calibrate the images and more accurately calibrate the images using dark frames. So it will close the shutter and take a picture of basically darkness with the shutter closed, and that allows you to subtract out hot pixels. It also allows you to subtract out some of the natural noise profile of the camera. But if the temperature changes, the thermal noise that's present in the image changes as well, and so that dark frame is no longer accurately subtracting out the thermal noise, and it's actually not homogeneous across the view, meaning it's not consistent. Actually, as the camera warms up, and normal cameras like SLR cameras, consumer single lens reflex cameras that you might buy, or even the P1000, the longer you do exposures with it, the longer it's on, the more it tends to heat up. And with this camera, I've noticed if you raise the temperature, the bottom of the image actually starts to get noisier faster than the top of the image. So it gets really messy looking if you try to subtract a dark frame that's not at the same temperature that the picture was actually taken at. And so that's really challenging over a long imaging session. If you're trying to do deep space photography like this, where you're doing 5-second long exposures, 15-second long exposures, and those are short for this camera. This camera can run for many minutes at a time. But for your typical consumer camera, these are, fairly long exposures. This Asteroid's bright enough, I don't have to go beyond that, but basically, if you're doing this over the course of the night, and you just have a typical consumer camera, and it's changing temperature throughout the night, the temperature of the night air is falling, but the temperature of the camera is fluctuating as the battery heats up. Maybe you have to change the battery, it fluctuates some more. It's a mess. Believe me, I've tried it. I've done it for years. Before I had this camera, I was using my Canon SLR as my deep space camera, and it was a bloody headache to get dark frames to accurately subtract out the noise from those images. And you would get down to the end of the night, and you would subtract your dark frames that you took at the beginning of the night, and it wouldn't necessarily work all that well because the temperature had fluctuated. But with this camera, it holds a set temperature, so even if it can't get to freezing temperatures like right now due to the humidity, it's still great because it's at least holding a consistent temperature and accurately subtracting out the noise. Additionally, it is capable of being hooked up to an adaptive optics unit, which I also have. So when I'm not tracking fast-moving asteroids like this, you can do really nice deep space photography. I mean, like I said before, this thing can run exposures for minutes or an hour at a time if you really wanted to. There's no reason to do so. It's better to just shoot shorter sub-exposures. But I'll typically do 5 or 10 minute exposures with the camera. With the adaptive optics unit, it will use a tilt-tip mirror to maintain a guide star at a very consistent position at a very high rate of speed, 10 hertz or more. And so it can do that much faster than the mount can do corrections through traditional auto-guiding. And as a result, you get a much sharper image, which is good. Oh, Steve texts me. Yeah. So, I got a friend who texted me about the clicking noise in the background. That's just the bug zapper. Sorry, I could turn that off. Actually, I've got bug spray on, so I'm protected. Alright, so all good there. So Skewy says, this is without a doubt the worst globe Earth CGI I've ever seen. Yeah, not CGI, but not really trying to photograph the Earth. Trying to photograph something going by the Earth. The clicking sound is NASA breaking your fingers to force you not to tell us we're all going to die. You guys are great. Equatorial telescope mounts equals round Earth. Mic drop. Yes, very true. Unfortunately, tonight I'm not running with the equatorial mount. For one reason, for one thing, just didn't have the time to polar align the scope tonight. And there's no point in doing so because I'm tracking a relatively quick-moving object here. So doing, 5-minute exposures isn't necessary. It's a bright enough asteroid that I can just do, 15-second exposures like this right now, and it's perfectly good. Interesting. I think that's a cosmic ray right there. See if that goes away in the next exposure. This thing on the right. Yeah, it went away. It's just a cosmic ray strike. Sometimes random radiation from space will actually strike the CCD and induce a charge. And it's occasionally get new hot pixels forming as well, which is what you're seeing here. Oh yeah, JPL lovers talking about going and getting pictures of Comet 21P using SLU. Yeah, SLU's a good service. Yeah, unfortunately I just don't have the scope set up tonight for Comet stuff. I mean, really, with comets, unless they're really close to Earth, it's better to do auto-guiding or adaptive optics and that kind of thing. So I've got the camera configured here for sort of fast object tracking without the adaptive optics, at least for tonight. How do cameras on tripods with 5-minute long exposures work from the spinning flying ground to space? Well, this camera can do 5-minute exposures no problem, but it's tracking with the Earth's rotation. Right now it's using that, it's doing that using altitude azimuth tracking, like your head looking up, down, left, and right. Very basic. So you get rotation, field rotation, when you do it that way, which is why we use equatorial mounts that are polar aligned parallel to the Earth's axis of rotation. So they only have to turn in one direction to compensate for the Earth's rotation. Doing it that way, you don't get field rotation. Basically, when you're doing very long exposures, 5 minutes or more, if you don't have your scope polar aligned, the stars will look like they're in the clothes dryer. I mean, it'll spin at the edges. Even if you're perfectly tracking in the center of the view, everything will appear to rotate around that point. And that varies depending on where you're looking in the sky, but it's a problem. So to get rid of that problem, you have to polar align. And that's why equatorial mounts exist. Oh, JPL ever got 100 images of the comet. Well, that sounds good. Yeah, stack them up. I don't know if I can receive them right now, but maybe you can drop a link. Well, actually, I guess you can't drop a link. I'm not sure what the easiest way of getting that to me is. Did I discover this object? No. No, I definitely did not discover this object. But amateurs have been assisting the professionals with gathering data on the object. Follow-up observations are very important. So what happens when an object like this is discovered? And it looks like the earliest images came from a professional survey atlas. At least at the moment, that's what's showing as the earliest images or data on the object on the Minor Planet Center website. Those may not be the discovery images. Sometimes the discovery enables astronomers to go back and look in plates or photos taken of coordinates that the asteroid was predicted to be at, but they didn't notice it originally, and then they find what they call pre-discovery images. Anyway, once they've discovered it, the clock starts ticking on gathering follow-up images, because time is a crucial factor in calculating the orbit accurately. To get an accurate determination of the orbit, you need to monitor it over time in order to improve the determination of the orbital elements, reduce the uncertainty in the orbital elements. You need not only a large number of observations, but observations spread out over time. So you want to observe it for as long as possible, and you want as many observations, high-quality observations, as possible. So amateurs do help out with that process. So let's see, scrolling down through the list here, I see a couple of amateur scopes. Great Shepherd. Pretty sure I saw a telescope in here as well. Yep. So there are multiple amateurs contributing observations of this object as well. The original telescope that found it is not continuing to track it. They leave that to smaller scopes to continue to do follow-up, while the big survey scopes continue to look for new objects. So that's how that works. So you'll have to give me a moment. I'll be back in just a few. And yes, to JPL Lover, I do have a email address on my channel. If you go there, you can email me pics. Did you guys see any aliens while I was gone? Sorry. I think I hit about a half dozen spider webs around my yard walking around just now. Jeez. A lot of spiders out tonight. Robert asks about whether this is a Leonid meteor stream or something. No, this is Asteroid 2018 RC. It's an asteroid about 70 meters or so in size, flying through the Earth-Moon system, between the Earth and Moon. Closest approach was about 230,000 kilometers earlier today, and it's now slowly receding from Earth, but due to Earth's rotation, my telescope's actually getting slightly closer to it, at least for the next couple hours. Assuming that's still true. I don't know. Might have already started receding at this point, even from my location. But anyway, point is, we're watching this close approach of this newly discovered asteroid, and the telescope is actively tracking it. It's the bright dot in the center, and the stars are streaks throughout the view. Robert says, that's what's causing the lunar eclipses instead of the Earth, according to the flat earthers. A 70-meter asteroid, who knew? Is it time-lapse? Oh, no, it's... well, that's an interesting question. It's real-time, but each exposure is 15 seconds long, so it's a slow frame rate, I guess you could say. And then it takes a few more seconds to download each image from the camera. It is a USB camera, believe it or not. You can still find S-Big cameras that are parallel port connectors. The older models are parallel port, the big old printer ports that you had to have to connect into those cameras. Fortunately, this is not one of those. How do flat earthers explain how people like Astronomy Live can predict stuff that we can find months later in the sky exactly where they are supposed to be? That's a very, very good question. Right now, in fact, all the tracking of this asteroid that you see here is being performed using calculations I ran myself and then loaded into a program that I wrote myself. So, explain that one. In fact, the latest observation of this asteroid that was used to create that calculation was from 2 days ago. And it's still good. It still works. Perfect tracking, no problem. I thought the voice was different, and thanks. Well, you're welcome. And yeah, I'm not your usual host for this evening. I think Red's watching, but I saw him in the chat earlier. But no, I'm not your usual host. Red has been kind to let me share the use of his channel so that I can stream, and any donations, any super chats, any ad money can be made on his channel, because YouTube is refusing to let me monetize my own channel. Yeah, I have a slightly different approach to streaming, I guess, or online online discussions, let's say, than Red. Not the usual approach. I hope you guys don't find it too boring or too off-putting. I like to think that I try to take the Carl Sagan approach. What's the speed? Ah, that's a great question. Off the top of my head, I do not know. What's the easiest way to figure that out? Radial velocity. Separate motions. Well, okay. I guess I could approximate it pretty quickly. How about 9, 10. What are we at? We're at 5:44 universal time right now. So radial velocity -2.4. It doesn't show me the units. I assume that's kilometers per second. So the radial velocity is still negative, meaning it's actually still getting closer to me. Yeah. Given my location on Earth, it's still continuing to close. Current distance at my location. Let's see. Actually, I haven't put in my location. I need to do that. Oh, you know what? Huh. I read the date wrong on the close approach, didn't I? I goofed. Yeah, I did. It's still closing on Earth. I read the date wrong. It was 9/9. Yeah, it's today. It's actually close approach isn't until let's see, we're at 5:40. 7 hours. A little less than 7 hours from now, about 6.5 hours from now is closest approach to Earth. So it actually is still getting closer to Earth's center. My mistake. I was thinking close approach was this morning, or yesterday morning now, not this morning. Yeah, sorry for the confusion. Okay, well that's good to know. So we're actually watching close approach happening. Very cool. Let's go there. September 9th. Current universal time, 5:46. So, oh, observables, yeah. I was wondering why I wasn't generating numbers. Okay, so if we take the relative velocity, well, let's do it relative to the center of the Earth, I guess, because you probably don't care about the top eccentric velocity, or maybe you do, but current relative velocity from center of Earth, -2.7, is that right? Yeah, -2.792. I guess that's kilometers per second. Now that's radial, so closing in at -2.792 kilometers per second. That looks about right, judging from how the range is decreasing currently. Then the lateral velocity. Let's see. I'm gonna really ballpark this. I'm not gonna try to be really super accurate about this. This is gonna be a really rough, and I mean really rough approximation. Let's call that 25 degrees negative declination. so that is, we're going to call that about 40 times that, 543, so 9 degrees, and right our ascension, 10, 2, let's say square times that, plus square root of 85 is 9.25. So 9.25 degrees per tenth of a day, or 2.4 hours. So divided by 2.4 hours, that is 3.85 degrees per hour. Now calculate angular, convert from angular size to physical size. And that is what? So 3.85 degrees per hour. Distance. Let's approximate that distance as what? 262,700 kilometers, thereabouts. So that is 17,659 kilometers per hour in lateral velocity. That sounds about right. That sounds roughly right. If I think I did that right. And that is 4.9 kilometers per second. So, okay, we've got a lateral velocity of 4.9 kilometers per second and a radial velocity of about 2.7 kilometers per second, thereabouts. There's your velocity. Roughly. If I did my math right. Which at 1:51 a.m. is suspect. Yeah, okay, JPL Lover calculated as 18,900 kilometers per hour. Was that total velocity vector, or was that lateral? Because I did them separately. Yeah, it's a fairly decent clip. It's moving right along. If it gets too close, maybe we could have Steven Tyler sing I Don't Want to Miss a Thing while Bruce Willis fights Ben Affleck. Worked last time. Yeah, sure did. Oh, thank you, Matthew Chave. Thank you for your donation. Appreciate that. Yeah, okay, so JPL Lover, that was lateral for you as well. Okay, yeah. Yeah, our numbers aren't too far apart. I was really spitballing, really ballparking. I was rounding like crazy on both the RA and deck motions there. I guess I could have just had it tell me the motions as degrees or arc seconds per second or something like that. But whatever. Show motion details. Yeah, I could have had it tell me arc minutes per hour for RA and deck. That would have been handy. Oh well, whatever. That would have made life easier, I guess. So this asteroid, that's a great question. What is its orbit like? It's got an eccentricity of 0.24, so it's fairly elliptical. Semi-major axis is 0.855 AU. So, looks like... and that is heliocentric, right? That's not... It's not geocentric coordinates or anything like that. No, those were heliocentric orbital elements, of course. And it looks like it gets down to a close approach to the Sun of about 0.649 AU. And I ought to know off the top of my head my asteroid classifications. You have your Atens, your Apollos, your Centaurs. Man, this is a good quiz question right here, and I should know the answer, and I think I do, but I'm not confident. You got your Apollo, Amor, Aten, asteroids. Yeah, so yeah, Aten asteroids are somewhat elliptical. They go slightly beyond Earth orbit, but then they dive closer to the Sun than the Earth. So I think they spend Aten asteroids spend most of their time inside Earth's orbit. I think that is true of this orbit. Yeah, I think that's true of this orbit. I think this would count as an Aten orbit, which was my gut instinct, but let's see, RC. Yeah, according to astronomynow.com, it's an Aten-type asteroid. So it spends most of its time closer to the Sun than we do. Kind of interesting. It's not an asteroid that goes and hangs out, you know, around Mars or anything like that. This thing gets closer and cooked more than we do. Let's see. Steps 0.01. Just doing some quick calcs on current distance. Looks like it's around. You know what? Let me get slant range. That's more fun. So from my location, it's at about 263,471 kilometers. According to my calculations. Let's see. Defizzle, obviously fake. LOL. JP. Was that a JK? I don't know. Figure sooner or later some flat earther is going to come in here and say it's fake. But yeah, so you guys just gave me an idea for a new feature on the next version of my scope tracking software. I need to have a button that, or just to have it automatically calculate the current velocity relative to Earth based on the ephemeris. That shouldn't be too hard to do. If I mean, I'm already interpolating current coordinates based on the list of coordinates. So. But yeah, I should have it read that along with the radial velocity and have it calculate for me the total velocity relative to Earth, and just have that given as a number to the user, so that I can answer that question more quickly when it comes up, because it comes up a lot when we do tracking like this, obviously. Oh, I got the email from you, Squee. Yeah, uploading my videos as unlisted videos, which I can link in the description of the edited video. I mean, I could do that. That's an interesting idea. I don't know if... And so, unfortunately, they're not very transparent over at YouTube about how they judge channels, whether, you know, they consider something to be too close in terms of duplication and stuff. I don't know if they take into account unlisted videos in their determination or not. I don't know. Maybe they say that somewhere, but I don't think they do. They're pretty opaque about what they take into account when they assess channels for monetization. So I'm not 100% sure that it would protect me. I could try it. Unfortunately for Falcon Heavy, my unedited video is the one that got all the views. I have like close to 400,000 views on that video. So I don't really want to put it into unlisted, you know. Now in the future I could do that, sure. But I'm not going to go through, you know, and delete my unedited videos like that one just because YouTube wants me to. I mean, that's absurd to me. So, yeah, this is Astronomy Live. This is not Red tonight. I'm a guest host for you guys tonight, and I'll probably be doing more live streams like this in the future from Red's channel, using my scope, since I currently can't take super chats or anything else on my channel. And I would like to, you know, fund the development of a permanent observatory here at my house, so that I can do a lot more live streams like this for you guys. So, you know, any super chats, any donations that come in will come to me, and I will set aside those funds for that purpose. Yeah, well, they won't let me stream it. Yeah, we were talking about, so the reason that they say they are not allowing monetization on my channel is for what they call duplication, which doesn't just mean live streams, they mean uploaded videos. And it doesn't necessarily just mean copyrighted content. I mean, I do have a lot of videos where I use Stellar Drone music, which I have permission to use from Stellar Drone himself. But they mean even original content, apparently. Other people who've looked into this and looked into channels that were denied monetization for this reason, in some cases, had no copyrighted content on them, no content from any other creators, it was completely original, but it was very similar from video to video. And so they claim that is duplication as well. And so when you upload a video of a rocket launch, for example, I don't live stream at the launches, but I record them and upload them. I'll upload multiple versions. I'll upload one that is unedited, raw footage, and then I'll upload one that's enhanced, and then, you know, upload maybe another a little later, doing a breakdown and analysis of the launch and comparison to simulation and all of that with the same footage. And then recently I did Falcon Heavy one more time, where I had created some new software for video stabilization and demonstrated it on that video, so it served another purpose again. And YouTube apparently really doesn't like that. But I do not feel compelled to alter how I run my channel just because YouTube doesn't like it. I mean, if they don't want to allow me to have monetization, fine. I'm not going to change how I run my channel in terms of doing analysis, in terms of providing, you know, both the enhanced version and the original version, just because YouTube says so. Now, a suggestion was made that I could upload the original unedited versions as unlisted, and that way they wouldn't count it against me. I don't know that they wouldn't count it against me. Hopefully they wouldn't, but there's no real way to tell. And then I could link to the unlisted videos when, you know, people attack me for uploading enhanced videos. And so I think that might help, but I'm not 100% sure on that. So, yeah, I don't know if my channel will swing back into their good graces. I'll make an effort, but I'm not holding my breath on it. I honestly am not. So I'm looking into other ways of fundraising for things like, you know, an observatory development. So the software being used to track this asteroid right now, I've written that myself, and you can find it on my channel right now, as a matter of fact, named Teletrack. And it should have a link to the torrent there, to the current alpha version. That's written in Visual Basic, but I'm currently porting it to Python. And right now, the current version is only compatible. Scopes will use the ALX200 command set, but I can't guarantee that it's compatible with those scopes. I haven't tested it on any other hardware. But I am porting it to Python, and in the process, that also makes it easier for me to utilize more functions of OpenCV for video tracking of rocket launches, things like that. And also, I'm going to be porting it to ASCOM, to use ASCOM protocols if at all possible, so that other telescopes can use it using universal ASCOM drivers. So I don't have to port it to every single kind of telescope. I can just port it to ASCOM, and a wide variety of scopes can use that. So I'm in the process of doing all that. And yeah, as Red says, there he is in the chat. You know, any donations that go to me tonight through Super Chat, they will go to me, and ad revenue as well. So all of that is going to be used to go towards the funding of a permanent observatory here at my house, which will make live streams like this a lot more frequent, because it means I won't have to set up the scope every night and tear it down every night. It'll already be aligned and set up. All I have to do is go out to the observatory and turn it on, pretty much. Now, you know, for special events like this, I may have to reconfigure a camera here or there. I took off the adaptive optics unit for tonight to track this asteroid, but that's easy to do compared to setting up the entire telescope. That's time-consuming and really restricts me to only doing this on the weekend, whereas, you know, asteroids like this can come through at any time. They can come in the middle of the week. And if the weather's good, I want to be able to do more live streams like this. So to do that, I'm going to need a, you know, permanent observatory. So the asteroid is getting lower in the sky. It's like it's catching up on Mars. What I'm looking at is correct. It seems like it's closer to Mars now than it was before, anyway. And it's definitely getting further into the southwest. I don't know how much longer we've really got until it actually sets over the tree line in the west. But I'm going to keep streaming it as long as I can here. It's a nice clear night. Oh. What's going on here? You guys can still see me or still hear me? I don't know. It said chat disconnected and then successfully connected. I'm not sure if I lost my connection there for a minute. Okay, it's back up. Okay, so I guess it came back. I don't know what happened there, guys. Sorry about that. I've got full bars on my Wi-Fi strength here, so I should have a good connection. And I have a really good internet from here, too. I mean, my internet connection is very high speed. So that shouldn't be an issue. But I see it did have some sort of disconnection event. Don't know why that happened. My OBS studio is reporting all green, so I don't know what's going on there. Huh. Still here and see you. I guess the hamster died. Yeah, some sort of weird streaming hiccup there. That is very peculiar. They don't want you to know the truth about this asteroid. I can't even imagine. Interestingly, I am noticing the field rotation. It seems like the stars are coming from a slightly different angle than they were before. Maybe they don't want you to notice that. No, but the tracking has been very reliable on the asteroid. It's been pretty solid, so obviously the orbit calculation that I ran on it is accurate. In other words, it's not going to hit Earth. You know, if I signal or just an artifact, but I'd say this asteroid has a little color to it, which is kind of cool. Huh. It just, I don't know if you guys can hear me. OBS reported that it disconnected and reconnected. I do Wi-Fi. There's no reason that should be happening. DDoS, maybe. Somebody's hacking. I don't know. It's weird. That is really bizarre. I don't know why that keeps happening. Yeah. So as I was saying, yeah, it looks like this asteroid might have a little color to it. Nice thing about one-shot color cameras like this, you don't have to switch through filters or anything. You can just record color live. Now, as it gets lower, it's going to get chromatic fringing, and I'm starting to see that definitely at the edges, like it's red on one side and green, blue on the opposite. That's chromatic aberration, and really probably mostly from the atmosphere at this point. This is a Schmidt-Cassegrain telescope, so you're really not going to get much in the way of chromatic aberration from the optics of the telescope, but you will get it from the atmosphere. Atmospheric refraction can actually cause that, from what I've seen in bright stars and satellites. And, yeah. take the color now with a pinch of salt, I guess, because the atmosphere itself is going to induce a certain amount of color to it, just as the sunset turns, you know, red from atmospheric reddening. JPL Lover sent me his pictures of Comet 21P, he says, through email. I'll take a look for that right now. Would you mind if I shared that in the stream, if I'm able to receive it here? Oh, that is a nice picture. Yeah. Okay, alright. JPL Lover is good with me sharing his picture, so I will share his picture of the Comet 21P. Let me see if I can pull that up here. So JPL Lover took this picture of 21P using SLU. I'm going to share that now. There we go. Should be visible now. It's a very nice picture of that comet. Cool stuff. Thanks for sharing that. You know, ironically, I should have pulled out my SLR camera to take a time lapse of this as we're tracking this asteroid, because right now the asteroid's getting closer and closer to the horizon. It's setting in the southwest right now, and won't be too much longer before it goes behind the trees. We got a little time, but I'm just thinking to myself now that flat earthers would take this as proof that it's coming crashing down to Earth. Proof the asteroid actually hit Earth because it went down towards the horizon. Just like they say every rocket launch, oh, it's going down into the ocean because it's getting closer to the horizon. Can't possibly because, you know, Earth's round. No. So here we have irrefutable proof the asteroid's crashing down towards Earth because it's getting close to my local horizon. Yeah, so Ravens Flies is talking about the foolishness of debating flat earthers. And, you know, if anyone watches my channel at all, they know I don't really do much flat earth debates. I do debunk things like Nibiru, but that's kind of my wheelhouse. But I still get a lot of comments from flat earthers, even though I don't really dabble in that very much. I mean, I've done things with red, like you know, measuring the altitude, velocity, and distance of the International Space Station, size of the International Space Station, all that stuff. I didn't do that exclusively to debate flat earthers, although, you know, it does rub them the wrong way. And so I got a lot of videos that rub them the wrong way, and as a result they will leave me nasty comments from time to time, or, you know, accuse me of faking my videos from time to time. The thing is, on YouTube, you don't have to seek them out. They seek you out. Especially if they see something that goes against their beliefs. It induces cognitive dissonance. They see something that they know can't be true while their beliefs are also true. So they have to find a way to minimize that cognitive dissonance in their minds. And the easiest way to do that, usually, is to expand the conspiracy to include whatever evidence would seem to contradict their beliefs. So, many flat earthers immediately latched onto the belief that, you know, the SpaceX landings are all fake, for example. And I don't know. Honestly, I don't even know why. I mean, I see obviously what rocket launches have to do with flat Earth and how that doesn't really jive with their beliefs, but in terms of it coming back to land, I think that had more to do with just their knee-jerk reaction to disbelieving anything SpaceX says or does. In any case, that's not working so well for them now, with all these amateur videos of the landings from Red, myself, and others. And so, if they want to continue to maintain that belief, they have to come up with some way of rationalizing that in their minds. And again, the easiest way forward to do that is to, you know, accuse my footage of being fake. So, they'll leave comments about stuff like that, whether I debate them or not. And it can get quite contentious after a launch in the chat or in the comment section. I've had people, and it's unfortunate to me because going to these launches, you meet all kinds of people from all around the world who come to see these things. And for me, I'm a local. You know, I'm there at tons of these launches, and until the end of the shuttle program, coming up on the end of the shuttle program, I really took it all for granted until I realized, you know, shuttle's not going to be around forever. And then I really started coming out to these launches, not just watching them from my yard, but, you know, trying to use my telescope and all my equipment to really capture them. And so you meet all kinds of great, incredible people, and they always ask me, the question I get most often at these launches is, are you uploading this online? Are you uploading your footage online? And the answer is yes. And I give them my YouTube channel, and at first that seemed great and like a easy way to share my footage with people who were actually there, you know, and wanted to see what the telescope saw. But more recently, what I've noticed is, like, sometimes they'll leave a comment on my channel, on my video of the launch, saying, it was great meeting you, you know, nice comment. And then they'll get attacked by flat earthers. In part, because some of them believe that, like, I'm faking my footage. They don't think there's that many people there, really. I don't know. They seem to latch on sometimes to the fact that my footage is, you know, really high magnification footage of the launch. And I don't tend to show the crowd very much. And so they say, well, where's the crowd? Well, then if they suddenly have a comment from somebody in the crowd, obviously that damages the point they thought they had against me. And so then they attack that person. And that person had no idea what they were getting themselves into. They thought they were just, you know, saying hi and leaving a nice remark on some guy's channel they met at the launch. And before they know it, there's flat earthers attacking them. They may not even have been aware that people are actually seriously believing this stuff online. You know, they probably thought it was all a joke. And so now I find myself somewhat embarrassed at times to give out my channel, because I know if they leave a comment, they're probably going to be attacked for it. And so I usually have to preface it by saying, yes, I upload my footage online, but be careful. If you post a comment, you could be harassed by flat earthers. And they look at me half the time surprised and disbelieving what I'm telling them, but no, it's true. And so earlier today I was watching that interview with Elon Musk on Joe Rogan's, is that his name? Rogan's channel. I never really watched it, but I heard Elon Musk was having this big, long interview, so I wanted to see it. And I watched most of it. I haven't finished it yet, but they got to the part where they talked about Flat Earth briefly. And Elon's response was, he thought it was all just trolls. He thought it was just people who, you know, were trolling and don't really believe it. And I can understand why he thinks that, but, you know, Joe Rogan points out, no, some of these people, they seriously believe this. And Elon still looked like he didn't really fully believe him on that. And I think I can kind of understand why. I mean, somebody in his position and with his experience and knowledge, he is so far beyond these flat earthers that he can't relate to that level of ignorance, I think. People forget Dunning-Kruger effect is a two-way street. Dunning-Kruger effect is this cognitive bias where if you don't know much about a subject, you tend to overestimate your skill level. And you tend to underestimate or underappreciate true skill in others. And it's because you don't have the meta. They understand the breadth of the subject much better, and they realize there's so much more to learn. So they rank themselves too low because they now have the metacognitive ability to realize that it is, whatever it is, has a great deal of skill that can be developed in it. So, for example, with Elon Musk, I think he is probably at a level where he can't fully relate to being that ignorant, and probably doesn't think people really are. Maybe it's, you know, trying to have hope for humanity, but, you know, people wonder why doesn't he do more to address these flat earthers? He, you know, pokes fun at them on Twitter, but why doesn't he do more to really, you know, disprove them? Put a camera here, put a camera there, show this, show that. Well, first of all, they're not going to waste the money just to piss off some flat earther. He might make a joke about it on Twitter, but he's not going to, you know, go out of his way to prove them wrong. And the other point is that he, like on this interview, he probably doesn't even believe they really sincerely believe what they believe, because he doesn't appreciate just how incredibly ignorant some of these people are. So, anyway, it's just an interesting thing I noted today while watching that interview. JPL Lover says this 2018 RC asteroid diameter is estimated around 2 kilometers? Really? What was that? Is that... You have a link for that? Is that a new... And unfortunately, every time I try to Google 2018 RC, some Lexus thing keeps popping up. Space.com says NASA estimated it at 130 feet, or about 40 meters diameter. I think that's maybe a bit conservative, but my 70 meter estimate's probably a bit aggressive. Astronomy Now says 70 meters. Where did you see it? It said Stellarium. Oh, Stellarium. Oh, well, I wouldn't... Okay. No, I wouldn't give Stellarium much credit on that. That's probably just bad info from Stellarium. Yeah, no, Stellarium is not a primary source of info on that. So I estimated the size based on Find Orb's calculation of its absolute magnitude, and that's from actual data on how bright it is according to the various observatories that have seen it so far, and then calculating the size based on an assumption of the reflectivity. And even with assuming a very, very dark reflectivity, about the same as asphalt, 5% reflection, you get a size around 70-something meters. And that's where you see that pop up in a lot of these stories saying about 70 meters. NASA makes a more conservative estimate, around 40. If you want to be really aggressive and say, well, maybe it's even darker than asphalt, maybe it's reflecting, you know, 5 times less than asphalt, then it would still only be in the 100-meter range. There's no way it would be 2 kilometers. That's just Stellarium being silly. NASA's uplink to your telescope keeps cutting out. Well, I hope the stream's working okay. It may not be. I don't know. I know we've had issues here tonight. Browser hijack. It keeps disconnecting me. Virus? I hope not. Jeez. I don't know what's going on there. Okay, yeah, I see OBS as being real screwy. It goes to 0 kilobytes per second on OBS, and then it pops right back up. This is really weird. I'm gonna try something here. I've never done this before. Well, I guess I'd have to shut down the stream. I'm tempted to try the backup YouTube ingest server, because it seems like maybe I'm having trouble connecting to the primary ingest server. That's where the stream is going to get taken in by YouTube. And I think it's having issues at that stage. And yeah, that's obviously not great. Okay, are we back? I think we're back now. Okay. On my end now, it seems to be solid. I went to the backup YouTube ingestion server. It seems like maybe the primary server is getting DDoSed or something, because it kept dropping out. I'm getting 2,600 kilobits per second pretty consistently now. Video bitrate. Okay, I'm lowering the bit rate way down. I don't know if that's going to help. I'm going to try it. This is really weird, though. I don't know why it keeps dropping out. I mean, my internet connection is fine, so... and I can still see the chat even after it drops out. It's not like my connection to YouTube is bad. At least in theory. It seems like... seems like it should be working. I do not know why it's acting up so much. Yeah, that's really weird. Could just be how it is tonight. I hope it doesn't do that next time as well. Yeah, it looks like a bandwidth problem, but I've got a 150 megabit connection here, at least. And I'm only using, 1 to 2 megabits up. And I've got, on the upstream side, I think I've got at least 15 of bandwidth. Maybe more. And I'm on a fiber optic connection. I mean, it should be fast as heck. And I got full signal strength on the Wi-Fi. I mean, there's really no reason it should be doing this. Yeah, I can still see the current chat when the stream goes down. It's not a problem on that end. So it seems like I'm able to see YouTube just fine. It seems like maybe there's something fishy going on with their ingestion server that's supposed to receive the stream. Yeah, it's switching to low res. different channel than surrounding hotspots. Not. I haven't really looked. I mean, we're not on zero lot lines here, and the only other Wi-Fi signals here are at very low signal strength, even outside. So I don't think it's interference from somebody else. And I haven't had any issues doing anything else anywhere else. Like, I've played around with Twitch streaming even a little bit, and it's not been an issue. The only other thing I can think to do is I could grab... I've got a Google MeshNet. I could grab one of the MeshNet pods, bring it out here, and hook it up with a wired connection to the MeshNet to the laptop. And that should provide even better speed. Shouldn't have to do that, though. There's no reason I should have to do that. So... I'm near Tampa, let's say, but not near Tampa. I'm on that side of the state, anyway. But I'm far enough from Tampa, I'm not getting any light pollution from Tampa, put it that way. Yeah, well, I call it a MeshNet. I guess that's the term, anyway. It's these little... I don't know what you call them. It's the Google Wi-Fi. It's these cool little circular Wi-Fi pods. And you throw them around your house to create a mesh of Wi-Fi around your house. And I got a bunch of them. And so you can also hook into them. Each of them has 2 Ethernet ports on the underside. So you can also hook up devices physically to them. And they have even higher speed than they've got really good connection between the pods. They're really, really powerful. Anyway, it provides good signal strength over the whole house, and I've got enough of them, and I'm to the house that I'm getting basically full signal strength outside. I'm pretty sure it's a 5 gigahertz router, so I could be wrong, but I think it is. Did it drop again? I haven't seen it drop since I dropped it down to 1 kilobit per second up. My connection is dropping. Okay. That's not right. Because I am... Yeah, I see I'm getting dropped frames. 219 drop frames. It hasn't gone up lately, but... yeah, I've done speed test. I'm not going to do it right now while I'm in the middle of a stream, but I've done it. I'll do it again after the stream just to make sure everything's okay. But I've done it before, and it's pegging the needle on speed test. So, and I'm still getting a green light on OBS. It hasn't gone to red since I lowered the upstream speed to 1,000 kilobit per second. But I should have way more bandwidth than that. That shouldn't be a bottleneck. So... yeah. It's really weird. Lagging. I don't know why it's lagging. Have a look at Letrix latency fix. What is that? Never heard of that before. I will take a look. Processor usage, currently 45%, 25% now. It's been holding pretty steady around 25%. This is why I was thinking have a BHO do a hijack this maybe. What's a BHO? It's a registry. Okay, World of Warcraft thing. It's a registry tweak. Yeah, not only is it, Kolobos says it's a 55-meter asteroid, less than 2 lunar distances. Yeah, it's about right. Only it's not 2 lunar distances. It's like little over half a lunar distance. It's about what are we at now? We are at about 2, let's see, let's do slant range, meaning topocentric coordinates. We're at 262,000 kilometers, thereabouts, 263 roughly, current distance. So, lunar distance, for comparison, is on average about 384,400 kilometers. Do you have any other tabs open? Well, I can close my tabs, yeah. I'm on this kill ping site now. I don't know, I was looking at that latency fix thing. Let me close my email, this page about Attons, other stuff. Yeah, I'm really not... the only other page I've got open is Minor Planet Center, and that shouldn't take anything. I guess I can close it, but that shouldn't matter. And I did a reboot of the computer before I started the stream. I restarted the computer, so it should be good to go. The only other thing I've got running, though, is I've got the tracking software running, sending commands to the telescope continuously. That does take a fair bit of processing power. There's nothing I can do about that, obviously. And I've done plenty of streams before tracking asteroids and such, and that's never been a problem, so I don't think that's it. Yeah, 263,000 kilometers, that's pretty close. That's a close shave. And good for the last several minutes? Okay, maybe I just had the upstream bandwidth set too high. It shouldn't have been, but I don't know, maybe the fact that I'm outdoors, maybe my bandwidth isn't what it should be. In that case, in the future, I may grab one of these Google MeshNet pods and bring it outside and hook up physically to it. Little added step, but if that boosts the speed, so be it. How's the quality look? Okay, now a little bit lagging has been improved, okay. Yeah, it's not going to quite skim the ozone, but it'll get within about 230,000, I think, kilometers. So, a few more thousand to go. Yeah, and Reds is not hosting tonight. I am your host for tonight, Astronomy Live. And we are looking at Asteroid 2018 RC. This is a near-Earth asteroid passing close through the Earth-Moon system, passing between the Earth and the Moon. Oh, there it got a little bit brighter, didn't it? Looked like it did, maybe. So I think we might be seeing some rotation there. It is currently about 263,000 kilometers away. And closing. Makes a close approach today to Earth. Just recently discovered, too. Asteroids this size, this asteroid's about 70 meters or so, give or take. And so asteroids at this size can sneak up on us at any time and even hit us with no warning, because our telescopes for detecting asteroids are really only designed to give us fair warning on asteroids that are about a kilometer or more in diameter at least, and so this is way below that. So we don't really get much warning on these guys. Oh, Colobos is in Titusville, yeah, right there at the Space Center. I hear there's a new hotel going up in Titusville, actually, for space viewing, actually. They're going to have, like, some sort of space viewing lounge or balcony or something. A Hyatt. Over there in the industrial park area near the the old Astronaut Hall of Fame building. Now that's, I guess, empty. But the Police Hall of Fame is there as well. Yeah, I know Titusville quite well. You going to do an animation of the asteroid through all the frames you captured? Yeah, I probably will. One more thing to put on my to-do list for tomorrow, I guess. But I'll try to process up a time-lapse. Since I'm taking 4 frames a minute, 15 frames here, or sorry, 15-second exposures, and I've been streaming how long now? I don't know, probably 3 hours, going on 3 hours, I think. So that's a lot of frames to process. Oh boy, I'm gonna have to batch process it. Yeah, we'll see how it goes. I might do a very quick batch process on all those frames to throw them into a time lapse. It'll make for a nice time lapse, though. The lines are stars in the background. Every image, though, is a single image, though. It's not a composite. This is a single-shot color camera. It takes color shots in one picture, using color filters over each of the pixels, just like a normal consumer CCD camera. So you are seeing, live images of the asteroid in real time. And the telescope is actively tracking the asteroid using software that I wrote myself. And I'm currently porting that software to Python, and hope to release it for a wider array of telescopes than just my LX200 Classic. Yeah, 30 gigabyte of oh god, I don't even want to know. I'm probably getting close to filling up the hard drive. Maybe that's the problem. How much, oh dear lord, how much of the hard drive am I consuming with this asteroid? I don't even want to know. Oh, I've got 300 pictures, really? Okay. How much space is that? These are all raw images too, FITS files. 1.2 gigs, that's not too bad. Those streaks are the stars moving. Yeah, in 15-second exposures. That's what's really cool about this asteroid. It's magnitude 12, so it's too dim to see by eye. You won't see it by naked eye in the sky. But if you have a decent amateur telescope like my 8-inch LX200, if you had just a regular eyepiece in here, you could see the asteroid moving by eye in the eyepiece, theoretically. If you had a I'd say at least an 8-inch would give you enough power to see a magnitude 12 star usually, I think. So. Yeah, hard drive space is pretty cheap. I just have to clean up this hard drive. I've got to offload files and stuff. I've got an external drive, which I think I've got like 6 terabytes on there or something, 3 of which are free. That's not a huge amount of space, but this is an older camera. This is an S-Big ST2000 XCM. It was top of the line in its day. It was a $3,000 deep space camera, but by today's standards, the resolution's quite poor. I mean, it's a 1600 by 1200 image. But when it comes to deep space CCDs, that's actually a lot of resolution. You pay a lot of money for a resolution with a deep space camera. You'd be surprised. You could easily pay $400 or $500 for a camera that's just a standard definition 640-480 camera. So it's nice to have a little more resolution than that, at least. And they also made the bigger brother to this camera was the ST4000 XCM, which, as you might assume from the name, had basically twice the resolution. If I remember right. Is that right? I think that's right. Anyway, yeah, more resolution. It's a good camera as well. But I think on that one, the infrared filter is sort of integrated into it. It's not really something you can remove. The thing I like about this one, there's no infrared filter built into it. So I can put a infrared pass filter on it that blocks visible light and only allows infrared light through. And we can look at objects that are visible in infrared light, like CW Leonis comes up in Nibiru conspiracies sometimes. People say that it's Nibiru because it looks really weird on Google Sky or what have you, and it's bright in infrared. So I can see that with this camera. So you can't see the asteroid by eye, too dim, magnitude 12. The dimmest you can see by eye is about magnitude 7 if you've got really good dark adaptation and you know how to use averted vision and it's really pristine skies. But this is magnitude 12, many times dimmer than anything you can see by eye. So you need a telescope to see it. And it's moving quite quickly, as you can see from the stars, so it's nice to have auto tracking like this. But if you had a good sky chart and an 8-inch amateur telescope, you could see it in the eyepiece. It's bright enough you could do that. And that's why with this camera I'm only having to run the exposures for a few seconds to see it. When will it be at its closest to us? Apparently about 12 o'clock Universal Time, so that's 8 a.m. I think. 8:30, around there. According to Find Orb anyway, and that's going to be roughly correct. So, close approaches. Okay, sorry, it's 9:42 Eastern Time. 13:42 Universal Time, according to Find Orb, is when close approach will be at a distance of 230,000 kilometers Earth to see the asteroid. Yeah, and I apologize for the stream hiccups tonight, guys. I'll try to watch the bandwidth in the future, and like I said, as soon as the stream's over here, I will run a bandwidth test just to see what's going on. Oh, where is it the most visible from Earth? Southern Hemisphere. It's got a negative declination. What's the current declination of the scope? Come on. Huh. My tracking window won't come up. That's weird. Tracking's still running, so I'm going to leave well enough alone there. But I want to say it was around negative 25 degrees declination, thereabouts. Yeah, negative 25.5 degrees declination, thereabouts right now. So if you were at about 25.5 degrees south and at a certain longitude, it would be straight overhead, so that would technically be the best place to see it. But even from here in Florida in the northern hemisphere, I can still see it. Yeah, and so, I don't know why I was having streaming issues. I know Red doesn't usually have streaming issues. I'm outside. Maybe that's affecting my bandwidth, but I have full bars on my Wi-Fi, and I'm not that far from the house, and I've got multiple routers placed around the house on this mesh net that are extending the Wi-Fi signal out here just fine. I've got one that's no more than 30 feet from me. So I should have a nice strong signal, and I do. So I don't know why it was giving me issues. It really shouldn't have. But I can make adjustments in the future if I need to try to reduce that. Yeah, from 40 degrees north. Let's see here. It's 3 a.m., so I'm having trouble doing the math in my head. But yeah, from 40 degrees north, it would be above your horizon, but not as high up as it was for me. So yeah, you're looking at 20-something degrees at peak, if I'm thinking right. 20 or no more than 20 or 30 degrees at peak. Maybe less. Yeah, no, I understand. It's a mystery to me. I don't know why I was having streaming issues, and it bugs me because I don't like technical issues like that. Worst part is I don't know what to do to fix it exactly. I'm going to try with, maybe bringing one of the mesh nets out here to try to improve that. Windows default sounds like one ding dong bell on the live stream. I didn't know the desktop audio was playing. Oh. Sorry, I didn't even know that was happening. YouTube is throttling a bunch of flat earthers, maybe on the overnight shift on YouTube. Yeah. Maybe they don't like me. Maybe they really don't like me. I don't know. What is it, the closest? 9:40 something a.m. Eastern Time, 13:42 or about 1:42 Universal Time in the afternoon. And I kind of wonder if maybe going to the backup ingestion server helped, although it did drop out there even when I went to the backup one, so I don't know. But the weird thing was it was showing the speed on OBS, and it wasn't having any trouble. Most of the time it was green, and then it would just suddenly go red. It would drop off altogether. So I don't know. That was weird. It's almost like my ISP was somehow throttling me. Maybe I should call Comcast tomorrow and sort of bitch at them. I don't know. I don't think it's their fault, but it is weird. Yeah, in like 6 hours or so, that's about right. 6.5 hours is when it'll be at its closest approach. Obviously not visible from Florida at that time, but it's okay. It made a nice pass tonight. It made a nice apparition in the sky for tonight, so I'm happy with that. And it won't be too much longer before it goes into the tree. So we'll be wrapping up the stream as soon as this asteroid sets here in a few minutes. Yeah, if I hate my spare time. It's okay. I've got a friend who works for them, so I've got an inside line into Comcast. Yeah, Spectrum, I used to have Spectrum. I would not, do not want that. I'd rather have Comcast. I never thought I'd say that because I thought I heard Comcast had issues, but Spectrum's worse. My pleasure, and thanks again to Red for allowing me to host this here on his channel. Yeah, FiOS is good. I had access through Comcast years ago before FiOS, and it was not great. But no, the Xfinity, FiOS, whatever, it's been good. It's been real good. No complaints. I don't know if it matters. I don't rent my cable modem through them, though. I have my own equipment, so maybe that helps. It'll be interesting to see when I put this time-lapse together if there's any real obvious pulsating of the asteroid from its rotation. I really hope to see that, but don't know. Well, time will tell. Oh yes, of course, the WOW signal. I've heard of it. Why doesn't the sun pull it into itself? Well, because it's orbiting the sun, and just like the Earth doesn't pull geostationary satellites into itself, this asteroid is in an elliptical orbit, but an orbit around the sun. Yeah, I think we are seeing some variations in brightness there. At this point, though, it could be from tree leaves. I don't know. That's above my pay grade, JPL lover. I don't get to hand out moderator hats. It's looking really reddened there, isn't it? And then suddenly it gets brighter. I swear that's its rotation. That asteroid's rotating at a good rate. Because it definitely changed in brightness there. And it's not like it got smeared out over more pixels. It just changed in brightness. So that's really cool. And this other star, you know, it's maintained pretty consistent brightness, so I don't think it was trees or other obstructions there. I think that was a true change in the light curve of the asteroid there. What would be the consequences of an asteroid this size impacting the Earth? Not much. I mean, it would potentially cause localized damage. So the Chelyabinsk meteor, or meteorite at this point, that was, let's see, that was thought to be about a 20-meter sized asteroid. So this is about 2 to 3 or maybe even 4 times that size. So depending on what it's made of or how structurally strong it is, it could do some serious local damage. Like if it fell on a city, good night, you know, it would kill some people. Chelyabinsk injured, I think, 500 people, and I actually have a piece of it in my asteroid collection, or meteorite collection. And that, like I said, was, you know, several times smaller than this thing. So if it fell and you happen to be standing under it, you would have a bad day. Now, 100 miles away, maybe not so much. But if it hit the wrong area, yeah, it could be bad. You know, if it hit downtown New York City, that would be, you know, Hollywood level bad. At least for downtown New York City. Yeah, Tunguska, exactly. So, Tunguska is a great example. There's a, you know, localized explosion that leveled a forest. But, you know, if you're hundreds of miles away, you know, not so bad. But if you're under it, really, really bad. Chelyabinsk, yeah, 20, what did I say? I meant to say 20 meters. Anyway, you know, 3 to 4 times smaller than this thing. What would be a viable plan to deflect this? That's a great question, and there's various thoughts on that, various schools of thoughts on that. There is thought about nuclear deflection. There was an actual study done looking at trying to use the SLS rocket, the big rocket that NASA's developing right now, using a variant of that to deflect a future asteroid using a nuclear-tipped missile, basically. There's less brute force methods, but require more time delay before impact, using things like, one of my favorites is the gravity tractor, where all you do is you park a heavy spaceship next to the asteroid and use ion thrusters to maintain a close distance. And gradually that heavy spaceship's gravity will tug it off course. It takes months, probably years, before it's tugged enough off course to miss the Earth, but it's a very controllable strategy. With a nuclear missile or something like that, you have a lot less exact control over where you're going to end up putting this thing or what you're going to do to it. So gravity tractor is one of my favorite strategies, but it requires a lot of delay before the impact. You have to know it well ahead of time. And with an asteroid this size, you're not going to know it well ahead of time. Some sort of brute force method is probably your only option, because we only discovered this asteroid days before it made its closest approach. So that's not really much time to put a plan together. I mean, pretty much all you can do is lob a nuke at it and hope you knock it off course enough. Would you? Maybe not. Yeah, I know, gravity tractor's out there, but I like it. It seems like an elegant idea, and I don't know. Guess I watch too much Star Trek. I want tractor beams. But more realistically, there's some interesting, I mean, it's still pretty far out there, but stuff like using the Yarkovsky effect by painting the asteroid white on one side, black on the other, or something like that, to spin it up and change how the orbit evolves over time. So oh, looks like we might be going into the tree. I think the asteroid's fading out, not because it's rotating and all the stars are fading too, because it's going into the trees. Yep, losing the asteroid. So it's now setting over the tree line, and that's going to do it for this webcast. Any last questions before I take off here? Yeah, I don't know if I'm pronouncing it right, but the Yarkovsky effect, that's from reflection from sunlight, yes. That's what causes that. And so if you alter the reflectivity of the asteroid, you can change how that effect works on the asteroid over time and manipulate its orbit without having to really do too much to it other than painting it, which is kind of interesting. Doesn't require much, you know, technical know-how per se, but it does require a lengthy lead time on it, so early detection is key. And that's also why we need to continually track these things, to know where they're going to be in the future, because if you don't get enough observations of this asteroid, like right now, if this asteroid's not followed long enough after the close approach by various observatories, then there may not be enough data to accurately predict its orbit into the future, and we could actually lose sight of it. And that's happened to a lot of asteroids, where there wasn't enough data collected on the initial detection, and so the orbit's not well enough known. Now, this one's popular enough that it's going to get a ton of telescopes on it, and there's going to be plenty of data. I don't think there's too much likelihood of not getting enough data on it. The big key is how long can they follow it before it gets too dim to follow. But yeah, length of time, having a nice length of time where the observations are spread out over is really helpful for determining the orbit more accurately and being able to catch it the next time it comes around. Being able to continue to track it and improve the orbit determination. So, thanks guys for watching. Thanks for coming out and watching this. And I hope to do more of this on Red's channel. Thank you, Red, for having me. And I'll see you all later. Clear skies, folks. Have a good night.